Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting video problem that I'm very excited about. So let's go ahead and read the problem statement. So the problem is called the minimum size subarray sum, right? So it says a given an array of integers, right, positive integers, right, and a positive integer target. Return the minimal length of a contiguous subarray, right, of which the sum is greater than or equal to the target. If there is no such subarray, return 0 instead, right? So that's a pretty good thing, right? So pretty much we're saying they're going to give us an array, right, and a target value. And then our job is to find a contiguous subarray, right, that's inside the array, right, that have a sum that's greater than or equal to the target, you know what I'm saying? So contiguous meaning right next to each other, you know what I'm saying? So for this example, right, the target 7, right, and then a subarray, right, a contiguous subarray that has a sum of 7 or greater, right? That's the minimum you could get, right? I'm saying, yeah, the minimal length, right? That's this one, 4 and 3. Just like we got this one, 4 and 4. This one, you target 4, right? And then we're trying to find 4. I'm saying 4 is the one that we end up returning, right? The length is 1, right? Because the subarray that has a sum greater than or equal is 4, I'm saying. On this one, the target is 11, right? But we don't have enough ones to really get to a target of 11. So that's why we return 0, because it said that if there's no such subarray, return 0 instead, right? So yeah, guys, so how are we going to solve this, right? Pretty much, guys, by looking at this, we could easily see this is a sliding window problem, I'm saying. So I did numerous sliding window problems on this channel, so I highly suggest you guys go check that out. There's a playlist, something will pop up, you guys could go check that out. So pretty much it's gonna be the same way, guys. So this is gonna be a dynamic sliding window, actually. So we're gonna have a left and a right pointer, right? And pretty much the right pointer's job is gonna help us in expanding the window, right? And then the left pointer, right, so pretty much we're gonna keep expanding, right? As soon as we get a sum that's greater than or equal to the target value, right, we're gonna pretty much trying to capture the length, right, and then compare the length of that window with the previous minimum length that we found, right, and update the variable accordingly, I'm saying. And then after we do that, we also have to shrink the window so that we get to a sum that's smaller, I'm saying. So that's how we're gonna go. So I'm gonna run through a couple examples all real quick. So let's go through the first example, right? I think it'll make a lot more sense. All right, cool. So that's what we have here, right? So we got the target and we got this, right? So we got the target of 7 and we got the array, right? So this is this problem that I'm doing right now. All right. So guys, yeah. Pretty much we got the left and the right pointer, right? I told you the right pointer's job is gonna help us in expanding the window, I'm saying. So now we have a sum variable, right? The sum variable is gonna help us in keeping track of the sum of all the elements that's in the window, I'm saying, in the window that we are considering, I'm saying. Pretty much all the numbers between left and right, that's inside the window, I'm saying. Then the minimum variable, this variable, right, is going to help us in pretty much keeping track of the minimal length that we've seen, I'm saying, so that at the end, right, we just return that, I'm saying. We just return the minimum length that we found, because that's going to hold the value of the minimal length that we found, right? So after we apply this algorithm, so now guys, let's go through the example, right? So right now we see a left, right? So they both start at the same place, right? So now we're gonna expand, right? So now we account for this number, right? So now the sum becomes 2, right? Because 2 plus 0 is 2, I'm saying. So now we check, does this sum, is it greater than the target? No, it's not. Is it greater or equal? No, it's not. So we keep expanding, you know what I'm saying? So let me go back real quick. All right, so we're here now, right? So now we account for 2. So now the next thing that we do, right, we check, does the sum, right, is it greater than the target? No, it's not, right? So now, guys, we just continue, right? So we at this step now, right? So we add 2 plus 3, right, gives us 5, right? Then we check, does 5 greater than or equal to 7? No, it's not, right? So now we keep expanding the window, guys, I'm saying. So now we're here, right? So now that's the window, I'm saying. Those are all the numbers that are inside the window. So now we see 2, 3, right? Now we have 6, right? That's 6. Is 6 greater than 7? No, it's not, guys. So we keep expanding, so I'm saying. So once we get here, right, we see 2 plus 3, 5 plus 1, 6 plus 2 is 8, right? So this gets updated to 8. And then we check, right? Is 8 greater than or equal to target? Yeah, it is greater than or equal to target. So now, guys, we're gonna keep track of the minimum. I'm saying the minimum that we've seen. So now we gonna say, all right, cool. We found a window that fits that constraint. You know what I'm saying? So now, what we're going to do, guys, we're gonna capture it. I'm saying pretty much is the target. So now, so the minimum. So now the minimum is gonna be calculated by doing right. So now the she's index. So 0, 1, 2, 3. So 3 minus 0, right, is 3, right? Plus 1 gives us the length of what? 4. I'm saying because there's 4 numbers, right? So now we found one, right? So now we see, all right, cool. So now we're gonna keep shrinking. So now we have to shrink the window so that we can see if we can find a window that's even smaller than this one, right? That's smaller, but that's a sum that's greater than or equal. I'm saying. So now we gonna pretty much shrink the left, right? So we shrink it by moving the left, right? I told you guys how we simulate the shrinking of the window, right? So after we shrink, before we move there, right, we need to make sure we subtract the value that was at the beginning, right? We subtracted from it. I'm saying. So now we put it's 6, right? Because we did 8 minus 2 gives us 6. So I'm saying. So we have 6 now, and then we achieved this 6 greater than or equal to 7. No, it's not, right? So now we still have the length of 4. So now we keep expanding, guys. I'm saying. So now we go to this one, right? So now we do 6 plus 4 gives us 10. What I'm saying. 10, right? So now we see 10 greater. Yes, it is. So now we check the length, right? The length is 4, so it doesn't get updated. I'm saying. So now we need to shrink it. I'm saying we need to shrink it because we got a sum that's greater. I'm saying. So we shrink it. So after we shrink it, we subtract 3. So now we have 7, right? So the 7, we still have the sum is still greater than or equal to it, right? So 7 is equal to 7. So now we check this subarray, right? So this subarray is smaller. So we, cool, we found a smaller one. So we update that to 3, you know what I'm saying? So now we shrink it again until we have a sum that's less than the target, you know what I'm saying? Because we want to find the minimal length one, you know what I'm saying? So now we subtract it. So 7 minus 1, 6, right? And then we have that now. So 6 is not greater than this one, so it's good. So we just go forward. Next iteration. So now we go to this one. Now we hit 3. So now it turns to 9, right? 9 is not greater than 3, right? So now it doesn't get the minimum value doesn't get updated, right? So now we shrink again, right? So cool, we're gonna shrink now. So we need to subtract 2 because we're not accounting for 2 anymore. So now 9 minus 2, 7, right? And then now we have a subarray that's 7, right? But the length is 2. I'm saying. So now this gets updated to 2. I'm saying. And then we do that, and then we do that until the length is smaller, right? Until the sum is smaller than the target. I'm saying. And then we see 3, 3. We subtract 7 minus 4. No, sum is 3. So now we exit out the loop. So now we return that, guys. I'm saying. So it's that simple, guys. So I'm saying. So hopefully you guys are able to follow the thought process and understand the algorithm that I'm trying to bring to you guys. So let's go ahead with the code, right? So now, guys, the code is going to be very intuitive. So pretty much, guys, we're going to start off. So I told you guys we're going to have the left pointer, right? Then we're going to have the minimum variable that's going to keep track of the minimum length that we've seen. You know what I'm saying? So now it gets initialized with a very big number. I'm saying because we're trying to find the smallest one. I'm saying we want the one with the smallest length. I'm saying. So now we get the minimum, right? So now the next thing that we're going to do, guys, we're going to add the sum variable that's going to help us in keeping track of the sum of all the elements that's included in the window that we have, right? I'm saying. So we're going to start our sliding window. So we see our right is equal to 0. What am I doing? Sorry, guys. So right is 0, right? Right is less than that length. You know what I'm saying. Then right plus plus, right? We keep incrementing, right? So now, I told you guys, right? Every iteration, right? We're going to pretty much add whatever number that's at the right side, right? I'm saying. So now we include that number in the or accounting for it in the window that we have, right? And after we do that, guys, we do a simple check, right? This is the check that I did, right? While the sum, right, the sum that's of all the elements, right, that's in this window that we're considering, you know what I'm saying, is it greater than or equal to the target, right? If it is greater or equal to the target, guys, what I'm saying, we're simply going to make sure that we capture it, right? We capture the minimum, like capture the length of it, right? And I told you guys the length is calculated by doing right minus left plus 1. You know what I'm saying? So after we do that, guys, I'm saying we capture the length, right? If it happens to be smaller than the previous min, that's how it gets updated. You know what I'm saying? So now we gotta be moving the left pointer forward, right? Because we want to shrink it, right? To simulate that, guys, we just subtract, guys. Subtract the whatever numbers at the left side, right? It's at the beginning, right? We subtract it from it. You know what I'm saying? And then to subtract it, we move it forward, and we don't account for that number anymore. You know what I'm saying? So that's how we simulate that, guys. You know what I'm saying? And then, guys, before we return, right, we check does the minimum value, right? We do that check, guys, because we want to know if we did find a subarray that that fit our constraint. You know what I'm saying? So we do that max. So if it never got updated, right, that means that we didn't find anything that so if it's equal to enter that max value, right, we return 0, right? If otherwise, we return min. You know what I'm saying? Yeah. So pretty much, yeah. If it never got updated, then that means we didn't find one that fit that constraint. So let's go ahead and press run and see if we pass the small test case. Awesome. Let's press submit. If we pass all the test cases, guys, awesome, guys. We're able to pass all the test cases, guys. I want to thank you guys for taking the time to watch this video. If you guys found value and you guys really like the video, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this, and I'll see you guys on the next one.